let us learn how to draw stuff in Python with a wonderful library called the Turtle Library. It's so cute. So let's get started with that. Before we get there, though, I'm going to open up the idle program just to get ready. And before we draw cool stuff, I just want to remind you what we studied before the midterm. It's probably gone out of our minds, and I understand that. So let's just remember what we did before, all the Python code that we learned before. We learned how to make variables, get input from the user, do some math, stuff like that. So let's just have a little quick review of all that, and then we'll get to the new thing. Okay? So let's do the following. Let's ask the user for two numbers, and we're going to save them somewhere. So let's make two variables, get them from the user with the input function. Remember those words? Maybe they'll type 2 the first number and then 3 for the next number. And then we want to shove those into some variables. Remember that we're going to have to convert some types. We'll get to that. And I think my goal is to let's compute the first number to the power of the second number. So if the user gives us 2 and 3, let's compute 2 to the third power, which is 8, and we'll just print it back out. So that's going to be our simple review example. All right? And so please yell at me if you are confused about any of this, because we're going to have to build on top of this now. So I'm going to make a brand new file new file in idle, and I'm going to save it in a place where you can have it. So you can save yours wherever you want, in your downloads folder. I just need to figure out what lecture we're in right now. This is lecture number 14. Okay, so back here, I'll make a new folder, so you'll have this after class. You can always come and find this in our code from class link, and I'll call it, I guess, POW is short for power computation, pow.py. All right, so there's my blank file, and here's the setup, right? I want to get two numbers from the user, and so I want to make a variable for the first one and a variable for the second one. So I want to get the first number from the user. Get the first number from the user. And I want to shove that somewhere. So to ask the user for something, it's the input function. We say input, and then between those parentheses, we put in quotes. It's going to be a string. Remember that word? It's going to be a string explaining to the user what we want from them. So this is going to be shown to the user as their type. So enter the first number, maybe colon space, because then it lets you type on the same line. Remember? And so we'll have some space to start typing it. And so then, once input works, what we get back is whatever the user gave us as a str. Remember that? So if the user typed 42 as their first number, we're getting back the str 42. Remember that? We don't like that. So every time you say input, even if the user has given you a number, they really wanted to type a number, you're just getting the text of that input. So you say input, colon, space, whatever, and then it's always a str that you get back. So if you want to do number stuff, then we have to convert the types. All right, so let's remember how to do that. So eventually, once we have the numbers, we can use the double star. That will compute the power computation. If I go to the REPL real quick, and be 2 star 3. That's what we want. Once we have numbers, that'll do the power computation. And that's going to be the end of that. We'll have to convert the types. And so I have to explain a bunch of low-level things that was not existing in Scratch. And so you might be a little bit bored for a few more programming lectures because we have to do simpler stuff. And I'm sorry, just have to work our way up to the Scratch level of things that we were working on. So in general, Scratch was holding our hands a lot. And I just have to write a bunch of more code now. We have to write more code in Python compared to Scratch to do the same thing. All right, but we get more power, right? We get more power, and we call that more low level. You're closer to the hardware. You're working on the bare metal, more like that. And so you can make your own version of Scratch. Everything that you did in Scratch, you can do in Python. It just takes a little bit of extra work because you have more control in Python, and that's a good reason to learn it. All right. So okay, we use input. We got back a str from the user. It's the quote's 42 or the quote's 2. I would like to convert the type. I would like to convert the type of this str to a number. Maybe the user is only going to give me whole numbers, so I'm going to convert it to int. Int is the type of whole numbers only, yes? And so if I take that str that I got from the user and wrap it around, pretend this int was a function, call it like that, then I will convert that type. I will convert the type of that str to an int, assuming it was a bunch of digits, okay? So the moral of this story is input, when you ask for something, I can spell input. Let's put it over here. If you ask for something from the user, you say input, you give your little prompt between either double quotes or single quotes. Python doesn't care. Those are both strs, like prompt : space. Then this will result in a str, which you can then immediately, if you want to, wrap it in an int call. It's like, take the int form of whatever that gives me back. Does that make sense? That's what we're going to do. That's what we did last time at the end. And then you can shove the answer into a variable. There's my num1, right? That all works together. So it's like, it's just the inner parts first. As the user gets the str back, convert, and then this is replaced with whatever the user gave. Then I get the str, convert it to the int. Now it's in a variable with the equal sign. Okay? Do we remember all that? Are there any questions about that? Let's watch it work at least. So, okay. Let's do that. And so here, input, we got the thing from the user. Make it an int, because it was a str. And then save it in a variable. Num1 equals whatever the result of all that was. Okay? Then I have it. And I want to do that for both numbers. So get the first number just like that. I can copy and paste, get the second number just like that. Second, I got to give it a new name, of course. Num2. Give me the int form of whatever the user gave me. So ask them for stuff. That'll result in a str. Convert it to the int form, and then shove it into num2. That will give me my 2, 3 as ints that I can do math on. Okay? You see it? We see the vision here? So, all right. Let's calculate now. Our goal was to take the power of the first number to the power of the second number. So calculate num1 to the power of num2 and print the result. It's the double star in Python. So we want to make, when we say print, the answer, it'd be like num1 star star num2. All right. And those are the 3 real lines. Everything else was a comment. All right. Everything with the number sign is a comment. And with all that work, we are ready. All right. So I'm going to do the 2, 3 example. Let's see if it works. Run module. Make it small. So enter the first number, : space. See, it's got my cursor on the first line. So it'd be like 2, enter. Enter the, oh, sorry, I was supposed to change this. Enter the second number. Here, let me rerun it. That will bother me if I don't change it. Enter the second number. So here, it's running again. 2 for the first number, now it's saying the second number. 3, enter. And then it got them. It got them both. It put them in the variables, and it took num1 to the power of num2. That was 8. And it printed that 8 out. That's why we see that there. Are there any questions about this program? Is it all coming back? We made some variables. We did some math on the variables. Remember that the print function can take multiple arguments, and so you can give it some stuff, comma separate those things, and it'll print them out with spaces in between. So we can be like, the result, I'll use single quotes for this string. The result is, and then just like by putting a comma, it'll print that str, comma, whatever that answer was, or space, whatever that answer was. So that's the goal. So now if I do 3, 4 this time, the answer is 81, but it says the result is space 81, and that's why. It's like comma, add spaces between the stuff as it prints, all in the same line. I think that's everything I wanted to say about this example. Are there any questions about it before I move on to new stuff? Kind of see the process, getting stuff from the user, converting types as we need to, printing out results of things. All right, let's learn new things now. So, all right, what I want to talk about for the rest of today is a wonderful library called the Turtle Library. And I'm going to give you a link down there if you want to go to it after class. But you just search Python Turtle, and it will take you to the documentation page, just like we searched Python Math before we went to the Math library page. So here's what the Turtle Library is. I'll always scroll down and see what you can do. It lets you draw stuff. It lets you draw stuff on the screen. There's a bunch of little functions that in the library that we can use. And here is the setup. I just noticed that the lights are on. I think there's so much glare that it doesn't matter. But make it slightly easier to see the screen. So here's the silly metaphor of the Turtle Library. It's very useful for us who are first learning programming. So the idea of the Turtle Library is there is a turtle. So let me draw a turtle. Boop. He lives in the library. There's his tail. And then he's got some feet. A little turtle. And somehow this turtle's tail got dipped in colored ink. All right. We can change the color later. We'll get to that. But the tail got dipped in ink. And this turtle is trained. We can command this turtle to walk around on the page and draw stuff, because he knows how to pick, like his tail starts down, he can walk, and he makes marks with his ink-dipped tail, all right? You'd ask him to pick his tail up and walk a little bit, then put it back down, walk some more. So that lets you create dashed lines, right? Stuff like that. And so with enough lines and enough movement of the turtle, you can draw whatever you want. Won't that be fun? So that's where we're going. So that's our goal. And yeah, there are different functions that do that in the library, like down puts his tail down, up puts his tail up. And let's talk about it. So I think the best first example is, let's use the turtle library to draw a square. All right. So the idea is, when you import the turtle library, we're going to have to say import turtle. And when you import the library, it's going to give you a screen. Right? It'll open up a brand new window when you run your program. I'll show this to you. And then the turtle's going to start his life in the middle of that screen, just like almost the Scratch cat, right? There is a coordinate system, just like in Scratch. So the turtle, our little virtual turtle on our screen, is going to start at the coordinate 0, 0. And then there's also a direction to the turtle, just like there was for the Scratch cat. He'll start out facing this way, which in the library documentation it calls east, right? So east. So that's the way he's going to be facing when he starts his life. So that's the goal. All right. So let me maybe move this up here, because I'm going to draw below later. So let's get that started. Let's draw a square eventually using the turtle library. So I'm going to make a new file in today's folder and call it square.py. Remember, you can call your file whatever you want, as long as it's not turtle.py. All right. Just like the math library issue, if you name your Python file the same name as a library you're trying to import, it will get very confused. All right, so you cannot call your file math.py. You also can't call it turtle.py. All right, call it anything other than those. All right, and now I'm allowed to say import turtle, and that will give me access to all the turtle library functions. All right, and so you can look at the page and see what's there. Just to prove to you that he's at 0, 0, let me just first print where he lives. There's a position. Where is that? There we go. There's a bunch of these little things. Those are set the position. So here are two ways to tell where the turtle is. They're synonyms. You can ask for turtle.position or turtle.pause, and that will give you the coordinates where the turtle is right now, and you can print those. So that's let's do that. So after this, now I can say turtle dot all day long and use the library stuff. So I can say turtle dot, hey, tell me your position. And then I'll print out whatever that position was. All right. So that's my goal. And now when I say run module now in the run menu, or if you type F5 or whatever it was, it will open up a brand new screen. Right. So here's the REPL. It's still going to print whatever you say to print over here. So there's my 0, 0. But here is the window in which we will make our beautiful artworks. All right. And so here's the tiny little turtle. He's visualized as an arrow right now, which I do not like, but you see he's facing right. All right. So the first order of business is, I think the turtle should look like a turtle. There's a library function for that. So it's, let's see, I think it's shape. So you can find this in that list at the top there. There it is. No. Where is your shape? There it is. It was in appearance. There it is. Turtle.shape. So if you say turtle.shape and you give something in between, you can give it the string turtle, like turtle.shape, and make him a turtle. Turtle.shape square. Right now he's probably like arrow. I think that's what he is right now. So we're going to make him a turtle. All right. So that's fun for me. Why not? So after turtle.position, I would like to make the turtle a turtle. So I say turtle.shape, and the library takes a string representing like one of the options, and that was what we want. I want him to look like a turtle, please. Make the turtle actually look like a turtle. And this is going to be so cute when you run this. So not only is he still at 0, 0, but now he looks like a turtle. Isn't it cute? So his color is determined by the color of the ink on his tail right now, ish. And so he's got black ink right now. That's the default. And he starts at 0, 0, and he's facing right or east. Okay, so that's the setup. Are we ready to make him move and draw stuff? Let's do it. All right, so my goal is to draw this square. And so we did turtle.position, and now we can say these things. You can say turtle.forward to make him go forward by a certain amount. You can say turtle.left to make him turn by a certain degree amount. There's also a turtle dot right. And then you can also change his speed. I'll show you that later. But like, let's say he's here. He's at 0, 0. He's facing this way. I can ask him to go forward in his current direction. His tail is down. I ask him to go forward, and he'll make a mark. Right? Let's say he wants to go forward. Let's move him forward by 100. Right? That'll move him over to here. Let's do that. So I'll say, the turtle dot forward by 100 units. Right? And the goal of this is just like you're asking to the turtle, pretty please move forward in your current direction by 100 units. So, Mr. Turtle, please move in your current direction by 100 units. There. Now when I run it, and you please try it as well. Look at him. He made his little mark. Isn't that cute? So now he's sitting at the edge of the line, and if we want to draw a square of like 100 sides on each side, we can't have him go forward anymore right now because he's still going to go in that same direction. So we need to turn him. You see? So he's facing this way. We want to turn him to the left 90 degrees. I think that's, or you could also turn him to the right and make a square this way, but I want to make this square. Yeah, does that make enough sense so far? Do you see the game? This will be fun. So here, he's sitting here right now, and if we told him to go forward, like this is his current direction, if we told him to go forward right now, he can make more marks that way. But we would like him to make this mark next, right? Another size 100 line. So in that direction. So to get from this direction to this direction, right, what we need to do is turn him to the left by a perfect right angle. By 90 degrees, please turn left, turtle. See how that'll get them in the right spot? So let's do that. It's turtle dot left, and then you give the degree amount between the parentheses. So, all right. Turtle dot left now. So turtle dot left 90. Look at him, he's ready. He's ready to go in the new direction. Isn't that fun? So you can do really fun stuff with this, especially once we learn loops in Python. All right, I hope you see the potential. So, yeah, his coordinates have also changed because we moved him. So, like, he's sitting at not 0, 0, but he went, like, forward in the x direction by 100. So now he's sitting at, like, 100, 0. Yeah. And we can prove that to ourselves. We can print out his new position. Be like, all right, here, we printed out your old position when you were back there, but after you moved, your position has changed. So if I print it again in between, we should see the new one, which is, so there was his first position. Now he's sitting here, 100, 0. Just like I'd said, all right? I think you see the game now. To do the actual square, it's going to like go forward again, 100, please. And then it's going to be a bunch of more left turns. So rerun. Boop, boop. You see it working? So now it's another left turn, 90. If we could use the loop right now, that would be very helpful, right? So there's that. Let's see here. Yeah, I think that's what I want to do. So just like you copy and paste it more or less after this. And let me just mark this one up. So like turn left 90 degrees, something like that. Forward 100. Okay, it's just going to be a bunch of repetitions of this because he was sitting here. Now he's at what? 100, 100. And then he's facing this way. We've got to turn him to the left 90 and then go forward again by 100. All right, that's our goal. That's our goal. I don't think I need to print that out this time. Just like some more of these. You see, I try to complete it as I'm talking about it because I need to take time to explain. So now I went forward by 100 again after turning left. Now it's one more left turn, right, by 90. Forward 100 one more time, and we've closed off our square. Yeah? So that should do it. We've got, now he's sitting at 0, 100, right? And then if we turn him to the left one more time, like he's facing this way, we want to turn him to the left 90 degrees again, face downwards, then go forward once more, and then we should be good to go. Boop. So, all right, one more. Just to prove it to you, right? Let's do the left turn first before the forward. Now he's ready, and if we go forward one more time by the same amount, we got our square. So I'm hitting F5 to run it quickly, but that's it. Look at it. Isn't that wonderful? Are there any questions about this? Does it make enough sense? This is very powerful, especially once you can start like filling in your shapes, changing the color. Like you can make some cool abstract art like this. So we'll get there. I think that's what I wanted to do. Let's see here. I think we're good there. Do I want to change that? Yeah. So let's show turtle.speed just quickly, because maybe one day you're going to make some fantastic work of art, and it's like it takes a while to watch the turtle move, like you don't have all day. So you can change his speed before he starts moving, so like at the top somewhere, and that will make him draw things faster. So there's a turtle.speed function here, this one, and you can give it a string again and be like turtle.speed fast or fastest even, whatever you want. So let's make it fast. I don't know what the default is. I assume the default is normal speed. So let's, I don't know where I want to put this. Let's put it here. After you become a turtle, let's make the turtle go fast. So I'll say turtle.speed, and then it just takes a string, a stir, that represents the speed you want here, like the things you can give it. And so I'll say fast between quotes. And remember that stirs in Python can be single quotes or double quotes. So like, just for fun, I'll say turtle.speed fast that way. And if I run this, whew, he was hyped up on caffeine that time. All right, so I think that is the first example. Does this make sense to us? Any questions about this code? The relevant code? All right, so if we are happy, I now have a question for you. So here, let me give you most of this code. So left, forward. It's going to take a second. Left, forward. And then it's just one more that was not visible yet. So here's my code. And my question for you is one more of those. There's the full code. And I'll make this big again. There you go. I guess I can make it a little bit bigger so you can see it in the back. Well, that's as good as I can do. My goal for you now is to take this code, and what I'd like you to do is try to draw another square. So we drew one square. Try to draw another square somewhere else. All right? So you can draw it in the middle if you want. You can draw it up over here. Pick the size, of course, changes. Draw it down here, wherever you'd like, but draw a second square, please. Maybe I'll draw my example down here eventually. But you may need the following. All right? If you want to not make marks for a split second, like the turtle's currently like right here facing downwards. If you move him forward, he's going to make a line. So if you move him forward with his tail down, he's going to make a line. So what you need to do is potentially the following. You'd be like turtle.up. Turtle.up picks his tail up, and then you move him, get him into position. He hasn't made a mark, and then turtle.down again to start redrawing. Start making new marks when you move. All right, so turtle.up and down, you'll need that. And then also turtle.setHeading is useful. That can just like force the turtle to move somewhere immediately to a certain degree amount. And so if you like from wherever he is, you can always move him up, down, left, or right, or any combination, anywhere in between. So if you say turtle.setHeading 0, that will face him east again, just like from wherever he already was. Doesn't matter. So you have to fiddle with lefts and rights if you don't want to. And then this is 90 degrees. This one is 180 degrees. And then this would be 270 degrees. Okay, so I think that's what I wanted to say. You could say that inside of setHeading, like 180, to like face him that way immediately. All right, up and down and setHeading, and then the rest of the stuff we already did. Try to make another square underneath after mine has already been drawn. Questions about the question? So please go off and try that. I can help you get idle installed if you're having issues with that. I can answer any questions that you have, but I want to give you some time to think about that, okay? give it a try. Sorry. So the documentation page is your friend. I'll give you a few more minutes to just play around. Like this is how you learn. That's cool. Try to draw a triangle or something. We'll do that next. I'll give you a few more minutes to just play around, because that is the best recipe for knowledge. Getting it? But yeah, just like you can go crazy if you want. It's useful to try. And I'll show you my answer in, let's say, 2 minutes. 2 more minutes. That's my timer, it looks like. Were there any questions that came up as we were trying this? Any weird things happen that I can help with? I'll show you my triangle, or not triangle, I'll show you my square. We'll do triangles next. I'm preparing for it. And then, hopefully that will help. So let's see. Just make sure that your file is never called that. What else was I going to say? Yeah, let's draw a second square, and I don't know where I want to put it is now the question. Like, you can put your square anywhere. You can go inside, you can go over here. Maybe I'll draw one to the right or something. I'll figure this out. All right, so here, let's at least say what we want. So underneath the first one, after drawing the first one, let's draw a second one. Let's draw a second square. And so I'll say, let's see here. Where are we right now? I guess is the first question. Which way is the turtle facing? I'll show you like set heading or something. Let's do, just for an example of set heading, let's have the square that we draw as my example. Let's have it be over here. So to get over there, I could turn the turtle left and move him, or I could use that set heading. You can also turn him right, but like by a bigger amount. I could just say set heading 0 to face him east immediately. Right? That's one thing that I want to show you right now. Let's do that. I will say that. So turtle dot set heading. If you say 0, that means east or to the right. And that will just immediately, wherever he was, doesn't matter where he was, it'll always face him that way. East way. Okay? So now he's ready. And I want to get him over to here and start drawing a new square. Kind of like the same bottom left, starting from there and draw that over here. Square. And so let's get him over there. And so it's like turtle dot forward by like 150, because like the old one's 100, you gotta go farther than that. And this is gonna like draw an extra line right now, right? Because he moves over there, and it's not as fun. Right? We have it's all connected right now. By default, it's all connected. So what we want is to just move him into position without making any marks. He was over here at the bottom left. We move him over here without making any marks. And what we got to do is pick his tail up while he's doing that. So there's an order to this all. Hope you see it. If you want to get him over there safely without making marks, you say turtle dot up. That picks your tail up. Wait, pick. Just ask the turtle, pick your tail up. And then you make your move. And then he's going to move with his tail up now, not making marks. And then once you're in position, ready to make new marks, once you're ready again, then you can put your tail down with the dot down. Does that kind of make sense? It's like, that's going to be the standard practice. Like, for a split second, take your tail up, move to where you need to go without making a mark, and then put it down again to make new marks later. That'll do it. Does that make sense to us? Like, we were there, we went forward 150 with our tail up, though. See the order? And then now we're down again to make new marks. So now we're good to go. Let's make a tiny little square. And so, yeah, let's do like a size 25 square. So turtle dot, go forward now by 25, and then like turtle dot left, 90. It's like a little baby square. There it is. See? It's right there. And so I'll just repeat that. I think you have watched me draw a square enough now. It's like you got 4 sides. You don't have to do the left 90 at the end though. It's gone forward 4 times, and left 3 times. Wait, look at it go! And if you need to, like, if you want to understand it better, you can change the speed again, like get rid of this line. You can delete the line to like make it draw slower. An easy way to like cancel out a line for just a split second, if you want to like keep it later, use it again later, is you can turn it into a comment by just doing that. And now suddenly that line has no effect anymore. Does that make sense? So now, like, I didn't change the speed anymore. That's called commenting out a line. That's very important. Very useful stuff. So now the speed is slow and nice and normal again. So there it goes. And now once you understand how it works, maybe you can change the speed back to fast or whatever. But there's my second square. Moving in a certain position, picking the tail up, getting somewhere, then redrawing, getting ready to draw that square. Are there any questions about this? Is it making enough sense? Alright. I think that's what I wanted to do for that one. Let's do a triangle now. Are you ready for a triangle? Alright. So, let's do an equilateral triangle. Okay, so again, we'll make a new file, and we'll start the turtle at like 0, 0. That'll be great. 0, 0. And like he'll face east. So like let's draw this triangle. This perfectly equilateral triangle, just like this, right? Go there, boop, boop. That's the triangle we want. Pretend that's perfectly equilateral. So what does it mean to be an equilateral triangle, first of all? Like all these angles are the same, and then all these side lengths are the same, right? Equal and equilateral, right? Does anybody remember what these angles are for an equilateral triangle? What are they? I have amnesia. Somebody needs to tell me. 45? Almost. The triangle's side lengths add up to 180, right? Or the angles add up to 180. And if they're all the same, it's 180 over 3. Yes? What is that? I think I heard it. 60. I'm going to tell all your math teachers on you guys right now. All right. So there we go. 60 everywhere. 60 everywhere. Yes? And let's make a big one. Let's do like forward 200 to make it forward big marked size 200 triangle. Let's do that one. So triangle. Let's do, I guess I want a lot of this before, right? I want to we'll steal a lot of this stuff from the square file. And I'll call it triangle. Just remember to not call it turtle.py, anything other than turtle.py. And yeah, we got a turtle. Print out its position. I don't know why. Don't really need that. But I copied it. It's fine. And then what I want to do at the very beginning of time, right? He's facing right. So here, let's save and run. Facing right. So let's make him go forward 200. Alright. And then we just like going to bring him over, right? Bring him over. So it's going to be a left turn, right? So he's facing this way. We want to turn him to the left. You may think that it is turtle.left 60, right? That would make a lot of sense right now, but that's not actually going to work. Watch. Turtle.left 60. And then forward again, right, by the same amount. Watch what happens. That'll work for what? 2, 3, either a pentagon or a hexagon, I'm not sure. One of those. But he veered off. Why? Why was turtle.left 60 not right here? Does anybody see it? He didn't go enough. Has it been too long since we took geometry class? Yeah. Good, yeah. Does everybody see how the angle that I want to turn the turtle is not 60, but it's whatever this one is. It's either the complementary angle or the supplementary angle. I can never remember the difference. So if you guys know, please tell me so I can memorize that. But do you see how this angle is not the one we want to turn by? It's this angle. Yes? What is that angle? Well, it's whatever this was, because they add up, right? It's a line, so it's 180 minus 60. Does that make sense, Jess? That's what we needed there, which is 120. That'll get us in the right position. We're not going to veer off anymore. So you can hard code it. You can be like, turn left by 120. Or you could be like, just let Python do the math for you. Just like, all right, I know it's 180 minus 60. Just like, do it. Calculate it. Turn left by that. Use the programming language to your advantage. So now we're in business. Awesome. So we do the same again, right? Turn left. You can imagine it's going to be the exact same angle. Another 120. Just like repeat this, just like we did for the square. All right. So there's a pattern emerging, I guess, for drawing regular polygons. Look at that. We got a triangle now. And he's back where he started. Veered off in a weird angle, which you can calculate. Or if you want to like make him straight again, you can easily change his heading with dot set heading. All right. So yeah, there's my triangle example. Looks like it worked. Are there any questions about why that code draws this? I think this is so fun. All right. You see it all working together? You thought you never needed to know geometry ever again. But nope. Now is the time. Now is the time to remember it. Okay, so let me now give you a fun example that's going to be very useful to you because I'm going to give you a programming assignment on this. All right, I'm going to ask you to do the same thing. So let me draw my initials using the turtle library. It's a little bit more complicated, right? So my initials are LN. All right. So we can draw an L pretty easily, I think. You can imagine that would not be very hard. Be like, L is just part of a box. It's like it's not a square, but it's a box. And so just like go a little bit more in the vertical direction than in the horizontal direction. Not a big deal. But then the N in my last name is a doozy. Let me try and make the prettiest lines I can here. That's going to be harder, all right? So let's figure this out. Let's figure these all out together. Let's start with the L, I guess, and then we'll graduate to the N, right? So let's say, I don't know, you start in the middle of the screen, right? 0, 0. I don't want to start drawing the L and there. I think, well, let's at least attempt to center the thing. So let's be like L, N-ish, kind of like that in the middle. And so I want to get to, let's say I want to draw the L like this, like we like to draw L's with our hands. So you start at the top. So like I want to get here, yeah. So I start in the middle. I want to like get over to the starting point of that L. Yeah, that's where I need to go. So with the tail up, I need to get to there. And the question is, where is there? Let's just say it's like, if 0, 0 is the middle, and I want the L right about there relative to the 0, 0, it's like a little bit up in the y direction, less in the y direction, less in the x direction. So it's going to be some negatives. Negative in the x, positive in the y to move up a little bit. Does that kind of make sense? So I picked a good number ahead of time. Apparently, starting the L at negative 200, positive 100 looks good. So let's get us there and go from there. All right. So that's my goal. Let's get to there and we'll draw our L. And here's my goal for the size. Like let's plan the size as well. Let's be like the height of this L is 200 and the width is, let's say, 125. All right. Same for the N as well. This will also be 200 by 125. It'll just look cooler. And then we also need a gap in between our letters. Let's have the blueprint ready to go. Let's say this is not to scale. Let's say that this is 40. All right. So that's I think that completely specifies now the entire shape, or all the shapes I want to draw. Okay, so let's get to here, negative 200, 100, and start drawing the L at least. That's not too hard, it's just a bunch of right angles. Let's do that one. So I'll make a new file, and I'll have it all look like turtle, have it look like a turtle and everything. So I'll copy the stuff from triangle, paste it in. I'll call it initials, probably. I feel like that's a good name, yeah. Initials dot py, all right? Let's see, what else do I want? Yeah, so here, the very first step is to get the turtle right here, so I can draw my L, just like boop, boop, all right? So get the turtle to this position. He's sitting at 0, 0 right now, all right? So the very first order of business is get the turtle into position. If he's sitting right here at 0, 0, we want to move him like over to there, okay? So the very first thing we should do is like point him to the left. He is pointing to the right at the start. So we can make him do a 180. That would work. Or we can say turtle.set heading. Right? So we can say turtle.set heading 180. That'll face him left no matter what. So let's do that just for practice. So I'll say turtle.set heading. Did I spell that right? 180. And now he'll be facing that way. And then let's get him to, he's at 0, 0. Let's get him to negative 200, 100. So let's go forward now by 200. That'll go negative 200, right? Go forward by 200. And then he's going to make a mark right now. I'll fix that later. So there he goes. And then we also, now he's at what? Negative 200, 0. We want to give him negative 200, 100. So It'll be nice and centered. So we want to turn them to the right now by 90. There's a turtle dot right, just like there was a turtle dot left. You can also do set heading. And then once he's facing that way, you can go forward by whatever you want, because that'll bring him up to a y equal to 100. This one. All right, does that make sense? That's going to get him into position. But it made lines, and I didn't want the lines. All right, does the getting him there part make sense to us? All right, yeah, just yell at me if you have any questions. I love this library. It's so fun. Let us get him there without making marks by using that up-down trick. All right, so the order really matters here. Before you do anything, Mr. Turtle, please pick your tail up, throw that up, and then, do you see how now he'll move? Tail's up, he's not making any marks. Now we're in position. Now we're ready to start making marks. Yes? So put the tail back down. Throw that down. Now he's there. He's ready. So now we're ready to draw. See it? And then, what else? What else? So, yeah, now it's time. Let's draw the L. Let's make it work. So, here, let me type some enters to get us centered in the screen. But he's facing upwards right now. You can make him do a 180 again, because like we want him to draw an L in a normal way. Like he's here. We want him to go down 200 right now. So we can face him downwards by making him do a 180. Or, again, we could do the heading trick. We're going to be like, turtle dot set heading. What is down direction? It's always 270. So be like, turtle dot set heading 270. That would work. Let's just do that. 270. Now he's ready. Look at him go. So now we can say, now we look at our blueprint. We want to go forward 200, right? Forward 200, left, and then 125. Forward 200 will get us the first part of the L. Look at how nice and centered that is. And then we're going to have him turn left. See it? Left 90. Not right 90, but left 90. Sorry, it's hard to put all this on the same screen. Left 90. And then he'll be in the right spot to draw the rest of the L. Boop. So now he's ready to go forward. Left by 125. Or sorry, forward by 125. Boop. Just like that. So if I run that, I'm typing F5 to run it quickly. I got my L. Does that make sense? Are there any questions about this code and how it draws that? It's matching our blueprint. That wasn't too horrible, right? So let's see here. What do I want to do next? So the next thing is we want to get to the spot where the end begins. Like I like to draw ends like that, right? So let's start it here. That's perfect because we're right here right now. We just want to like hop over to get to there, yeah? How do we do that? 40 space in between is what we planned, let's say. We want to just go, like are we faced in that direction as well? Yeah, we're already there. We're already faced in that direction. We just need to go forward by 40 without making a mark, yeah? Because that'll get us in the right spot. Forward by 40 without making a mark. And I think you can see what's got to happen. It's like turtle that up, pick your tail up. You're in the right direction already. Go forward by that amount, by 40 to get there. And then we're ready to like put our tail back down. So this is the space in between. Space in between letters. Yes? I'm going to say turtle dot down, because then we'll be in the right spot again. It's always up, down, up, down. Do you see it working? Just like that. So you jump the gap. So up, move, forward, move, and then down. Now we're ready to make new marks and start the end. Yes? Any questions about that? You still good? We're getting there. So now the end's the hard part, of course. So now it's time to draw the N in my last name. So turtle's facing. Turtle's sitting right here, facing east. We can just do a left by 90 to get him in the right direction now and go forward by 200. That would work. So turtle left 90, forward 200. I guess most of the way there. There. And now we are at the hard part. Okay. Now we need to go down. We need to turn right-ish, right? Turn right by some weird angle to get to there to make it so that the side length is exactly 125, and we go up. So let's use green to talk about what we need now. So we're sitting here. We want to go this way. Like we are facing this way right now. The turtle's facing that way. He's up. We need to make him turn that amount. Yes? Whatever that amount is. What do we have at our disposal? Like, it's the opposite of this angle, right? The complement or the supplement, whatever you call it. It's like 180 minus whatever that is. Can we find this angle easily? Do you have any thoughts? Do you see what's emerging here? It's a trigonometry problem, yes? Because this right here, you better believe is a right triangle, yeah? How can I find this angle? What do I have? I got the opposite, I've got the adjacent. What do I need? Which one's opposite over adjacent? The tangent. Do you see it? That's how I find that angle. I know that the tangent of that question mark angle is 125 over 200. Does that make sense to us? You never thought you needed to know this ever again. Perhaps. Now you do. So, all right, to find out the angle, then it's the inverse tangent. It's like tangent inverse of that, 125 over 200. We have that in the math library. We're going to use it. Python math. You see how this is all coming together? Is a great example of a bunch of things. So there's a normal tangent. And then, where is it? Here's the normal tangent. You say math.tan. And the inverse tangent they call arctangent. So it's math.atan. Math.atan, whatever you want, and that will give you the inverse tangent. All right? But you get the answer back in radians. And we need to control the turtle using degrees, unfortunately. So, all right, we're going to use the atan function. We're going to get the angle in radians. And then we can convert it to degrees. We can convert it to degrees. There's just a function for that as well. It's just called degrees. It's like math.degrees of something in radians will give us back the degrees version of that. Does that make sense? That's going to be the setup. Look at it all work together. So then we'll then fix it. Okay. So that's going to give us the right angle to move by. All right. Does that make sense enough to us before I do it? This is weird, I know, but we need that knowledge now. Here, all right, if I need the math library, stuff in it, I need to import the math library just like I imported the turtle library. Finally, I need another one. So I got that, and now let's figure out these angles. I can put them in variables, right? That's the use of this. Let's save all this in a nice way. This is like the angle equals, it's the inverse tangent of that, right? So it's math.atan 125 over 200. Like, you just have Python do the work. It's fine. And then this answer, what we get back from atan is a radians amount. We want a degree amount. All right? So we can take that answer and say math.degrees on it. See how it's good? It works this way from inside to outside. It's like, does that, and then it does that. That's the goal. And then we're happy. All right? Do you see how now angle is going to hold the degree amount of that question mark angle right there? Does that make sense to us? It's a lot going on at once, I know. But like that's what we need here. All right, so we got the angle. And then, all right, we finally have it. We're facing this way. We want to turn the turtle right by 180 minus the angle. Yeah? Whatever it was. We can print it out later if you want to figure it out and see what it really was. That's what I want. Turtle.right by whatever that was. 180 minus that angle. All right, we can print the angle just for fun. Print the angle. But all that work, he's ready. He's ready to go forward by the length of that side. And that's the next question. I need to go forward by this amount. I'm in the right direction now. I need to go forward by that amount. How can I find that amount? This is a length, L. What do I need? Again from math class. What will give me that length? Any ideas? It will. Very good. Yeah, so Pythagorean theorem, we got a right triangle. We've got a squared and b squared, right? We're finding c squared. So L squared, right, is equal to a squared plus b squared. So 125 squared plus 200 squared. If you just want the length, you take the square root. That's going to give us L. Do you see it? And that's the amount to go forward by, whatever that was. All right. So the square root function is math.sqrt. So that was my length L that I needed. Oh, man. So now we know. Cool. I'll say L. We'll say that in a variable just for fun. L equals math.square root of 125 squared plus 200 squared. Isn't that fun? And I want to go forward by that amount. By whatever that length L was. And this is, the font is weird. This is not a number one. This is the lowercase L. All right? Lowercase L. That's what I use. You can call it whatever you want. Call it len, length, whatever you'd like. And we can print that too. Print whatever L was. Boop, boop. Beautiful. And it looks like the angle was this, a very weird one, and the length was that, which makes sense. It's bigger than 200 because it's wider than the up and down 200 part. Are there any questions about that? Does that make enough sense? We needed trigonometry here. That was fun. All right. And then we're home free. All right, because you can do the same thing. This is like there's a term for this, right? Opposite, alternate interior or something like that's the same angle there. We're gonna do the same game just in the opposite direction. It's like instead of turn right by that amount, it's gonna be like turn left to get back upwards. You can also do set heading since it's straight up. Whatever you want, but we are home free now. Okay, we made it. We made it. So let's we want to turn. It's going to end up being turtle.left by this idea again, 180 minus that special angle. Instead of a right turn, it's a left turn because those angles are similar. Those are the same. And then we go forward. Like here, let me prove to you that that's going to put them straight up again. Straight up. And then go forward by the height of our letters, which is 200. And what do you know? We've got my initials on the screen. That's a little complicated. Do all the pieces fit together in your minds? Are there any questions about that? Very important that you guys get this, because I'm going to ask you to do the same thing in your next programming assignment. I'm going to ask you to do your initials, as well as some numbers too. Does it make enough sense? I'm going to give you the code as well to study. I just want to make sure we're all on the same page right now. Yeah? All right, look at that, it's fun. So let's see here. I had to show you the hard way because there is an easier way to do this. If you want, you can figure out the coordinates. Like, all right, that coordinate's that one. That coordinate's this one. That coordinate's this one. That coordinate's this one, this one. If you plan out the coordinates, you can have the turtle warp to coordinates with the goto function. All right, that would have solved this problem, but in a less educational way because it would have been so easy. So you can make this easier on yourself with turtle.goto. And so here, let me just show you that, and you can look into it if you'd like. Turtle.goto. You say there's a bunch of synonyms like either turtle.goto, turtle.setPos, turtle.setPosition. But what you do, you say turtle.goto, and then you give some coordinates. Like, here's the example with the setPos. You could just set turtle.goto instead. It's like go to 60, 30, that exact coordinate. Then it'll just warp the turtle there, regardless of his current direction and all that. All right. So you can use goto to very, very quickly get somewhere. I'll show you more of that next time. But if you plan out the coordinates, that will also make it easier. You don't have to use trigonometry if you're able to do that. Okay. But this is a great example of using two libraries together. So I had to do it this way. All right. It's more fun. I think that is the end of my initials example. Are there any questions about, and then also these slides, are there any questions about anything we talked about today before I move on to the next thing, the next assignment? You ready? Let's see here. Yeah, those are all the files I want to do. But here, let me show you an example of goto real quick. Maybe that's what I want. You just say like turtle.goto. 0, 0 or something. That'll just warp the turtle there, regardless of its current direction. Watch what happens at the very end. Warps right there. It's gonna drift right to the middle there. And so that would have made our lives easier. So feel free to use that one if you want. I'll comment this out so that it does not affect my pretty picture when you run it later. But like that's what GoTo does. Just like warps you to a certain coordinate. All right. So I think that's all that I wanted to say in the lecture today. The last thing I want to talk about before I let you do whatever you want is your next programming assignment. So here is a new programming assignment for you. Are we back on track now? Where is this one? So you got one due this week, right? And then here's a new one. This one will be due next week, right? So here's what I want from you. So let's see, what do I want? First of all, everybody, or no, I'll do that at the end. Here's what I want from you. So here's your Python, your first Python programming assignment, all right? What I'd like you to do, please, is write a Python program that draws your initials. So just like I did today, draw your initials, as well as some numbers. So please draw the year, just like the last 2 digits of the year that you want to graduate. The year that you plan on graduating from here or wherever you transfer to. So for example, like I graduated in 2020, you could say LN20. That would be my example, all right? So in addition to your initials, I want your graduation year, please. Just the last 2 digits is fine. You can do the .go-to, make it easier on yourself if you'd like, but I just wanted to get you some practice with this. So in addition to this, draw your initials too, right? We're all on the same page, so initial is graduation year. Yes, initial is graduation year, we're going to do that. All right, so that's what I want. Don't forget your 2 digits. I just did a screenshot of what we did. And so yeah, you may have some very difficult letters in your name. Like you may have another N. Even worse would be like if you have a C in your last name. Like that would need a curve potentially. There's a way to do that. I can help you. Look at the documentation, see if you can figure it out. But there is a way to draw curves in the Python library, and that's like not like a full circle or something, like an arc, stuff like that. That's possible. I highly encourage you to look into it. But for this assignment, just like make it easier on yourself. If you can't figure it out, just like draw a blocky C. Does that make sense? Like do it as easy as you need to do it. All right, so just draw a bunch of lines. Just like draw a bunch of chunks of lines if you need to. It'll all work. Okay, so just use straight lines if you'd like. So yeah, your initials and the 2 digits that of the year that you want to graduate. So that's what I want to see. Okay, and so yeah, just to show me that you understand, just make a video, please. Explain your code as usual. It doesn't have to be long, as long as you get through all of it. I want to watch it draw, right? Walk through your code, show me it working, and that will be your programming assignment. So you can use a lot of the stuff that we did today, all right? That we do next week. Questions about this one? All right, and those of you who have been doing alternate programming assignments, those of you who've been like doing the racket assignments, if you programmed before, from now on, I want you to do the Python ones too, all right? But I would like you to go above and beyond to the extent of your knowledge, please. So like you should be doing the curvy letters if you have like a C or a P as an initial, something like that, okay? So please, or a D or whatever you need. So try to go above and beyond the basics if that applies to you. But yeah, from now on, everybody's doing the same exact assignment. And we can make it harder for you if you would like, just to keep it interesting. Yeah, I think that's everything that I wanted to say about this programming assignment. It's out. It's available for you to see, and I will give you the code from today. You'll see it in the code from class link in just a few minutes after I clean up everything. Okay? Any questions about any of that? I think that is all that I want to say for the day. That's all I got. The rest of the time's all yours. So make sure to do attendance. I forgot to stop that. I'll stop that in like a minute if you haven't done it yet.